A few months ago, Waveshare beat Raspberry Pi to the punch with their PoE HAT F. I tested that, and now I have one on my Frigate Pi at home and another one on a Pi at the studio. A PoE HAT lets you run power and networking over one Ethernet cable, so you don't need a power adapter anymore. You just need a HAT on top to take the PoE power and convert it into the 5 volts the Pi uses. Raspberry Pi's been dragging their feet on their own Pi 5 PoE HAT, but after seeing some of these new HATs, I'm kinda okay with that. These third-party HATs have a new party trick. They add an M.2 NVMe slot alongside PoE support. That's handy because that would simplify this setup. Instead of running the Pimoroni NVMe base for an SSD and the Waveshare PoE HAT for power, I can just have one HAT with everything. Let me demonstrate. I can plug in this Ethernet cable, and in just a second, my Pi will start booting off this fast NVMe drive in a tiny little package. No need for an extra USB-C power supply, and no slow, unreliable microSD card. It's perfect if you're racking up Pis or running them remotely. This HackerGadgets version even has cutouts so it fits inside the official Pi 5 case. Whether that's a good idea, we'll see later. I'm going to test each of these PoE plus NVMe HATs, and at the end I'll pick one to go into my mini rack, which is just dying to get an upgrade from the old Pi 4 in there right now. Now, generally you'd use a PoE switch to power multiple devices, like this one I have in the rack. But for my testing today, I'm using this Aruba PoE injector, the PoE 60U. It plugs into your network, then injects power over Ethernet into the network cable, so you can just plug in any powered device, like this Pi, and it'll power it over the same cable that carries the data. I'll have links to everything I talk about in the description. First up, the 52Pi M.2 NVMe M-Key and PoE Plus HAT. This thing has pretty broad NVMe compatibility. It takes any size up to 2280 size NVMe drives and provides enough space for the Pi 5 active cooler, which it actually includes in the box, and there are holes cut into the board to allow it to breathe through there and get input for the fan. The power circuit does 5.1 volts with 4.5 amps of power output to the Pi, so you can run pretty much anything. It's not quite the 5 amps that the Pi requires for full power USB, but honestly, most things will work fine on here. It also has a pass-through GPIO header, and that lets me still use the GPIO pins on top of this if you want to have another HAT stacked on top. There are also power pins on top for 3.3, 5, and 12 volt output, and this whole thing fits exactly within the Pi's total footprint. Now, the one thing that's a little annoying about this hardware is this little FFC cable goes through a hole in the middle of the board here. That's I think they do that so that they can fit the NVMe directly on top of the Pi without having to extend over it or anything, but that does make it a little bit awkward when you're plugging this in. It's not impossible, but I did use a little tool to plug it in. The temperatures on here are pretty good. The hottest IC on it is a little bit further away from where the fan is, so it could get a little hot, but in the open air, at least, it only got up to 50 degrees Celsius. And another good thing is I didn't hear any coil whine at all. This is a problem sometimes when you have a transformer. You can kind of hear that kind of high-pitched sound. There was none of that on this board, even with my ear right up close to it. That transformer is a bit tall, though, so that is one thing about this design that's a little different. It has this capacitor over here and a transformer that's pretty high up off the board, so it makes for a taller solution, which may or may not work depending on what case you want to try this in or if you're putting it in a rack. And it has activity and power LEDs, but there's no LED indicating whether or not the board has PoE power. So you can plug it into PoE and shut down the Pi and those will go off and you're not 100% sure if the board has power or not. It's nice to have an extra LED if you can, so that you know that you're plugged into a PoE jack on your switch, even if the Pi is shut off. And speaking of shutdowns, I did run into a bug on this board. By default, like just flashing a Pi and running this with it, when I shut down the Pi in software, like I say sudo shutdown or I use the shutdown option, the PoE HAT seems to reset its own power in addition to the Pi's power, and that causes the Pi to immediately boot back up. So if you shut it down, it boots back up after about a second or so. And the same exact thing happens if I press the physical power button on the Pi 5. So there's something with the way that this power works that's not really the same as the other ones, because the other ones didn't have this problem. And that might not be an issue if you're going to run your Pi 24/7 and always want it to boot back up anyway, but I thought I'd at least point that out because the other HATs didn't have that problem. Now I did reach out to 52Pi and they said that there may be a setting you can change that'll fix that. I haven't tested that yet, but just be aware if you buy this one, that could be an issue. Now the HackerGadgets NVMe and PoE HAT is a little bit different. It's only compatible with 2230 and 2240 size NVMe SSDs, so it can't fit the full 2280 SSDs. And it also has something that's unique. I haven't seen this on any other one yet. It has a special USB-C power delivery input circuit to allow powering it from normal USB-C power adapters, including the one from Raspberry Pi. But you can use other ones too that aren't just Pis that have more standard sets of power output. So you could use a 9-volt or 12-volt USB-C PD adapter that's more common like for laptops and things, and this will down convert it for the Pi. So that's an interesting feature. It also means you have a safe input for USB-C that doesn't backfeed through the Pi. And under here, you'll see there's a little cutout. There's a pass-through with mounting holes for the case fan. And I'll get to how it works in the case a little bit later. But this actually includes 2 screws. If you want to use the case fan with this board, you can screw them in using those 2 screws. Or it's also in about the right place for the active cooler, which I have mounted here. And that'll go underneath it. And both of these line up great and pull air through the board and actually get a little airflow through all these circuits and through the NVMe drive, which is nice. But one issue I did find is if you use the case fan with this and have this strapped to the top of the Pi, it actually, one of the screws on the case fan bumps into the heatsink that comes with the case. So you can't use the heatsink and the case fan at the same time. Or you could, I guess, move the heatsink and kind of mount it off center, but that wouldn't do this much. This board gives 5 volts at 4.8 amps of power output, which is enough for most things, about the same as the Pi's power adapter. And the temperatures on this board are good. The hottest I see on it is right next to where the fan cutout is, so that should help. Even if it does get a little bit hot, it'll at least get airflow. Now, coil whine was interesting. On this transformer, I could hear a little bit of coil whine in this quiet room. It wasn't bad, but it was audible from a foot or 2 away. It just wasn't that loud. I've had PoE hats that are a lot louder than this, but I did want to point out that it is there. And this board has 4 LEDs on it. It has one for USB-C PD power input and one for PoE power input, which lets you know if the board is powered up, even if the Pi is powered off. And it has power and activity lights. The activity light blinks when the NVMe drive is accessed. So this board has a lot of easy ability to kind of debug everything just by the LEDs on top, which I really like, especially if you're deploying this in a rack without, a monitor or something. You can really see everything that's going on here. And the FFC, this flat flexible connector that it comes with, designed by HackerGadgets, I noticed that it was very slightly off-center. It works fine at PCIe Gen 3 speeds, but it was a little bit annoying to get plugged in. I had to kind of plug it in and then put the board on top. And the board, you could use a pass-through GPIO adapter, but it just comes with a little one for the end here. Now, using this with the official Pi 5 case is kind of the party trick that this board has. It's a good board overall, but it actually can fit inside the Pi 5 case, which no other PoE hat that I've tried does yet. And it does that by kind of cutting corners, quite literally, on the board so that it'll fit inside with the top cover on. That might not be a great idea. I put it together that way, and I measured thermals with the top on, top off, and with it out of the case. And basically the fan is running all the time, and if you do any sustained activity at all, the CPU will start throttling. This isn't a problem with this hat, this is a problem with the Pi 5 case. It's basically like a little easy bake oven for your Pi. I mean, just look at the graph. This is how it runs compared to running it bare outside the case in my 25 degrees Celsius office. It's really night and day difference. And this third one is the Enfuse SBC PoE RPi 5 M.2-M, and there's actually a bunch of different options. There's a B, an E, an M, or even a mini PCIe version of this board. So you can use it with a bunch of different devices, the different versions of it. Now, this is a very low profile board, and you might notice as you look at the different sides of it that it's missing something that could be considered important, a transformer. And I'll get to why that might be important later. But it's also very low profile. In fact, it's so low profile that this little capacitor on the bottom kind of sticks into where the active cooler fins would be, so you have to break off a couple to use this with it. It actually calls that out in the installation instructions. It'd be nice if they could find a way to design this without that, but I think they had to do that because they put all the power circuits under where this cutout is for the fan, and they also have a cutout for where the camera cable and display cables are. So kind of some design trade-offs there. This says it supports 5 amps, 25 watt power delivery, as long as you have active cooling on the Pi. Otherwise, this thing will probably get a bit too hot. And my test unit that I got actually didn't ship with the accessory kit that it comes with. But from what I can tell, they're shipping an FFC, and they're shipping one that's not like this one. This is impedance match. So you'll see it's kind of a different color. It's not white. And it has lines that are kind of put together so that there's a little bit less interference. Usually that's not an issue, but sometimes I have seen problems with non-impedance matched FFCs, especially if you're using PCIe Gen 3 speeds. So, that's just something to keep in mind. But especially if you don't care about pushing your SSD to Gen 3 speeds, it's not a really big deal. But what could be a bigger deal is that lack of an isolation transformer. Now, I asked Infuse about it, and they said that their design is not isolated. The advantage of their design is certainly that it supports PoE.BT and is pretty efficient. Now, in general, especially in common use cases, an isolation transformer won't really cause an issue if you don't have one. But it can cause problems in some cases, probably even blowing up your Raspberry Pi, especially in kind of fault conditions. So I generally don't really trust a PoE device without any isolation, and there's a reason the PoE standard requires it. And that's to prevent things like frying the CPU in the powered device. And yes, while I was doing my research on this, I did get nerd sniped into reading this entire paper on PoE isolation. But Infuse did mention better power efficiency, and I guess, if you're taking out a whole part of the circuit, that might be more efficient because there's less for the power to go through. And I compared it to the HackerGadgets board, and the Pi did use almost a watt less power at idle, but that's close to the margin of error for my smart outlet, so I can't say anything definitive about the PoE circuit Infuse designed, except I wish it had the better isolation, because I imagine that there's a reason why it's recommended and why it shows up in all these other devices that do PoE. One thing I did really like about this design is there's 3 little debug LEDs on the bottom. It says Type 1, Type 2, and BT, and it helps you debug what type of PoE power your Pi is getting. With the Aruba injector that I was using, it's supplying Type 2 BT, meaning I'm getting the full 25.5 watts of power that I can get to the Pi. Some simpler or older injectors or switches can give a little less power, and you can use these LEDs to kind of diagnose how much power you can actually get to the Pi through your switch. And with that power, the thermals are actually kind of interesting. This inductor got up to 60 degrees Celsius, but what's weirder is the edge of the board with those status LEDs was actually getting up there too. I asked about it, and Infuse said it was expected and the temperatures are within spec. Now, once I installed it, besides having to modify my active cooler and break off a few fins on the heatsink, there weren't any major problems, but there were a couple circuits that kind of bump into the fan screws on it, and they're not touching on solder joints, so it's not really an electrical issue, but it is a little bit annoying, and I imagine if you had it in a high vibration environment, that could kind of wear things down over time. I didn't hear any coil whine at all, and that's probably because there's no transformer, but it was absolutely silent in use. And unlike the 52 Pi board, shutdown worked fine by default, and it's nice that once you shut it down, you can still see the power status and the PoE power type indicator LEDs while the Pi is turned off. So for this mini rack, I'm going to stick with the HackerGadgets hat. It's nice and compact, and while it does have a tiny bit of coil whine, it seemed to have the least design compromises. And since I'm going to run it open in the rack, the heat in the Pi case doesn't really matter at all. But to make this portion a little more fun, I'm going to install it wearing a shark costume. And you know what the shark costume means, Surfshark. While I'm fumbling around trying to unscrew this rack shelf, someone else is prying away at your private data. Governments, advertisers, ISPs, and websites, and Surfshark has tools that can help you with privacy. Now, I'm not going to lie and say that I only use Surfshark, or using Surfshark will magically make everything untraceable, but it is useful. I have another Pi running WireGuard. It's a private VPN I use and manage to get access to my internal network, but that means I have to manage the Pi, a firewall, and a domain name to use with it. If you don't want to manage all that, Surfshark has you covered. Certainly better than I am with my shark costume, which I had to open up to get at a couple of the tiny M2 screws. But even with my own VPN, I still use Surfshark. Like when I travel, Surfshark lets me still access the sites I need, even if they put up silly geo restrictions. Surfshark has thousands of servers around the world, certainly a lot more than I could cram into a mini rack like this one. And if you're worried it's not for you, they have a 30-day money-back guarantee. Ah, there, the Pi's upgraded and ready for a mini home lab. Secure your privacy with Surfshark. Go to surfshark.com/redshirtjeff for 4 extra months. There are a bunch of other hats coming out too. MCU Zone makes 2 different size hats for both size drives. And Waveshare added 2 more PoE hats to their lineup. One has an M.2 slot and the other one is a tiny Model G. This one looks like it also lacks an isolation transformer, so I'm not that excited about it. But more will come. Maybe Raspberry Pi will even launch their own someday, but I'm not going to hold my breath for that. I didn't test a couple things today though. I didn't see what happens when backfeeding USB-C power. Some of these designs might behave better or worse in that condition. What I typically recommend is you don't try plugging in USB-C power when you have one of these hats installed. Some hats, like the P33 from 52Pi, explicitly tells you not to. I also didn't push each of these to their maximum current ratings. I typically would just run an SSD on this thing and maybe a medium power USB device like an SDR. But bottom line, even if Raspberry Pi never releases their own design, I think we're pretty well covered at this point. More details linked in the description, and until next time, I'm Jeff Geerling.